Hey everyone, it's Colin, how's it going? In a previous episode, we tore down and modified this little amp for my garage stereo project. This time, let's take a look at the speakers. So the garage stereo project continues. Last time we looked at that little amp. This time we're looking at the speakers. Now, these aren't just regular speakers. It would be easy for me to have just gone out and bought regular speakers and hooked them up. But you know that I don't really do it that way because one, that's easy. Two, it would cost money to do that, and I'm trying to do this whole project on the cheap. But also three, because you just wouldn't end up with a video. So here we go. Some of you may already recognize this speaker, but I'm guessing a decent number of you won't. Prepare to groan. Oh no, it's the four-letter word. People love to hate Bose for some reason, and other people absolutely love to defend it. The deal with these speakers is, one, it gives us something interesting to kind of dissect and take a look at how they work. But the other thing is, and the primary reason why I'm using these speakers, is they were free. They were gonna get thrown in the recycle pile. They were no longer used. They hadn't been used for a long time. I figured, you know what? It's probably worth a video about these. So some of you may recognize as being Bose Model 101s. Here's the catch though. They're not actually 101s. They're very similar though. These are actually Bose Model 102s. These are the professional version basically of the 101s. They came out in like the mid 1980s and they've had a few different kind of iterations and models all based on this same design since then. But the 102s differ from the 101s really in just one major way, in that they're designed for commercial installation. And if you look at the back, you'll notice this extra little rotary dial switch here. That's pretty telling as to what's going on. So let's start tearing this thing down, and then I can explain how this thing's different and then what we need to do to modify this speaker and the other one just like it for kind of regular home audio use. Now, the first thing you'll notice after I took that grill off is that it's just a single full range driver. There is no separate tweeter on this speaker. And this is a very classic Bose design. In fact, I did a podcast episode a while back talking about how Bose kind of works and their philosophy around sound and the criticisms surrounding all of that. I'll include a card up top and a link down in the description if you want to watch that episode. It proved surprisingly popular. I'm kind of baffled by that. But this is a classic Bose driver design. It's a 4.5-inch full range speaker, which has its own bits of compromise, which we'll talk about a little later. This front baffle fits into the rest of the enclosure so tightly that I found it's actually easier to take the speaker driver itself out, and then you can use the hole to help, you'll see, to get more leverage to pull the rest of the baffle out. Surprisingly beefy magnet on the back of this driver. I guess that's the one thing Bose did correctly. You've got this kind of foam plastic gasket on here to provide a bit of a seal against the front baffle there. So now we can start pulling the rest of the screws out. You can see kind of these little protrusions down in this channel. When this thing starts to come loose, believe it or not, those little plastic protrusions are actually very sharp, and I have the scars to prove it. So I'm gonna put on a pair of gloves because I don't really feel like bleeding on camera, and I don't think you want to watch me bleed on camera. Although I'm sure some of you would say I would deserve it for working on a Bose speaker, but that's neither here nor there. Yeah, the gloves were a good idea. So what's the story with this transformer down in here? Well, like I said, this is a commercial speaker, and that's really the main differentiator between this model 102 and the Bose 101, which is almost identical otherwise. I think to explain best what this transformer and switch does, let's just do a quick diagram to kind of go over the differences between commercial and home audio speakers. Okay, so here's the deal with that transformer. Let's start by talking about regular like stereo systems at home first. So you've got an amp and you've got some speakers. And let's say you have 2 speakers in one room and then 2 more speakers in another. And let's suppose that maybe this is just a 1-channel amplifier. Maybe you've got 8 total speakers, but we'll just look at 1 channel, 4 speakers total with 1 amplifier, just for the sake of this whole discussion. Between the amp and the speakers, you obviously have some speaker wire. So with a single channel, the easiest way to wire that all up is going to be like this, where you've got 1 speaker hooked directly to the amp, and then the other speaker paralleled off of that first one. Now, with these set up the way they are, let's just say each of these speakers is 8 ohms. Those 2 together will present a 4 ohm load on this amplifier, which generally is fine because most audio amplifiers are rated for somewhere between 4 and 8 ohms. It's going to depend on the amp, of course, but the majority will run like stable. They'll be happy between 4 and 8 ohms of impedance as a load. As you add speakers, the impedance, however, is going to drop. So with this scenario, with just 2 speakers hooked up in parallel, that's fine. However, what happens if we decide to hook up the other 2 speakers? Well, these speakers could be identical. Maybe these are the exact same speakers and they present each the same 8 ohm load. However, wired in parallel like this, it's not going to be 4 ohms at the amp. Instead, it's going to be 2 ohms. And that is too low for that amplifier. Chances are it's not going to have a very good time. It won't be efficient. It may go into thermal overload protection. Overall, you don't really want to do this. Now, this is the exact kind of setup that they actually want to do in these pro audio installations, because if you think about the typical layout of a store or restaurant or whatever, you're going to have a whole bunch of speakers all over the place, but you don't need stereo. Commercial power amplifiers and all of this setup is generally going to be done in mono because you're not going to have the opportunity to listen in stereo. Remember, this is just background music. But the way they want to wire all of it up is going to be as easy and as simple as possible for them. And that generally means wiring speakers up in parallel, where they're just daisy chaining the next speaker off of the next as they go throughout the building. Yes, I know that there are certain configurations you can do with wiring, specifically running things in series and parallel, that can present a better impedance load on the amplifier. However, that gets to be way too complicated for a commercial install, especially with the wiring nightmare that you kind of end up with. And it also doesn't give very good flexibility. So this generally is not going to get seen in commercial use. You're going to see one of these like 70 volt kind of systems instead. So let's take a look at that. We'll start off the same way, where we've got an amp and then 4 speakers. Now, they're going to want to wire them up the same way. However, with these commercial systems, there's an additional little bit going on in the middle, and it has to do with that transformer. On the amplifier side, you're going to find a transformer hooked up to the amp's outputs. At each of the speakers, you're going to find a transformer hooked up to each of the speakers' inputs. And then you'll see your like daisy chain parallel wiring going on between all of that. That rotary switch on the back of the speaker, what's the deal with that? Those are all different power taps on each of these transformers internally. What it allows you to do is select basically how much power each speaker is going to get fed. And that makes for some really easy math for figuring out not just how big of a power amplifier you need to specify, but also whether you can add on speakers later on based on how much volume or power you need to get out of all the speakers you have now. So typical switch options on those taps are going to be like 1 watt, 2 watt, 4 watts, 8 watts. These Bose speakers we're taking apart have a maximum tap of 25 watts. So let's just use that as a simple example. So let's just say each of these is set to the 25 watt tap. To figure out how much power you're going to be drawing off of the amplifier, you just add them all up. These 4 speakers are going to be 100 watts. Now, maybe we decided to be a little forward thinking and specify a 200 watt amp. Cool, now you've got some headroom, meaning that let's say later on down the road, this is in a restaurant and they decide to open a patio and they want some speakers outside for music out there. Cool, you're only drawing 100 watts here, you've got a 200 watt amp. You can hook up 4 more 25 watt speakers and just continue on with the daisy chain off of the last speaker or tap it anywhere in the middle. It doesn't really matter. You still have the capacity at the amp. But what's the deal with the transformers? Why step it up to 70 volts? Well, that all comes back to the whole impedance thing. Remember with that home example, we said 4 speakers wired in parallel, even if each speaker was 8 ohms, presented a 2 ohm load on the amp. The cool thing about using these transformers is they kind of isolate that out. So the transformer hooked up to the amp is going to be presenting the amp with an impedance load that it wants to drive. It's going to be somewhere in that 4 to 8 ohm range. We'll just say, for the sake of argument, that the transformer is giving the amp an 8 ohm load. Now, each of these speakers are themselves, like the driver's going to be wanting kind of the same thing. They're going to be rated for 4 ohms, 6 ohms, 8 ohms, whatever. And the transformer can drive the speakers at whatever they're rated for. So maybe these are also 8 ohms each. By stepping it up to 70 volts, you're really kind of taking that out of the picture. The other thing you're also doing is eliminating any worry about line loss or additional resistance from the long cable runs themselves. You think about this being in a restaurant or a store, you could have hundreds, if not thousands of feet of speaker wire between the amp and the speakers. And generally, if you weren't using transformers, that would represent a very real and very measurable drop in impedance across a very long run like that. It'd be something else you'd have to take into consideration with what kind of amp you specified and speakers and all of that. The transformers take that all out of the picture. It's kind of the same concept as those really big high tension power lines that deliver high voltage electricity maybe to your neighborhood, and then it gets stepped down in like a neighborhood transformer to the regular AC voltage that you get into your house. Same concept. They don't need to put these big, gigantic, fat power cables from the power station to your neighborhood in order to handle all of the line losses you would otherwise see. They step that voltage way up because it's able to handle lower, thinner gauge cable much better. It's a way more efficient way to transmit electricity. Kind of the same concept going on here. You can get away with like 14 or 16 gauge cable over hundreds, if not thousands of feet, because you're bringing the voltage level up and allowing yourself to just keep daisy chaining on speakers and make the most of the power amplifier's capabilities. If you're curious as to the age of these speakers, there's a label on the back of this particular driver that lists a date of February 94. Now, these drivers have actually been in production for quite a long time, and they're the same as used in some of Bose's other Pro speakers, specifically the 402s and the 802s. And they were also used in the iconic, well, I guess in quotes, iconic Bose 901 sets of speakers. The interesting and weird and somewhat frustrating thing about these drivers that we have to deal with is they're not a standard impedance driver. These are actually about 1 ohm, as opposed to the typical speaker driver, which is somewhere between 4 and 8 ohms. So that's something we're also going to have to take into account when we deal with rewiring this for kind of traditional audio use. Ultimately, I think the plan is to simply pull that transformer and selector switch out of the circuit. I don't really want to deal with them but I'm just gonna wire all the way around these, the transformer and the switch. I'm gonna go straight from the input terminals, which you can kind of see in the back under there, and through some extra circuitry that we need to add, and then directly into the speaker driver. Now, despite the fact that this is a full range driver and questionable audio design, lots of people love to hate on Bose, one thing that I will give them credit for doing correct is the construction of the driver itself, specifically the fact that it uses a fabric surround. A lot of speakers, I would say the vast majority of speakers, are built with a foam surround, and that foam surround tends to break down over time. Some speakers for specific applications use like a butyl rubber surround, and those generally last way, way longer. But for general purpose speakers, it's always these foam surrounds, and you'll maybe get 20 or so years out of them before just time and UV light and age and everything gets to them and they just start crumbling to nothing. This one they actually used a fabric surround on. It's still in really good shape and it should last a very, very long time. So even though I plan on using these speakers in the garage, I actually expect this driver to hold up just fine because of the quality of the surround on it. So what's the challenge we're going to face inside this speaker in terms of making it sound acceptable? Well, let's talk about the way most speakers work. We'll just take, for example, a regular two-way bookshelf speaker. In a two-way speaker like this, you're going to have a tweeter and a woofer. The tweeter is going to be pretty small, maybe an inch or so in diameter, and the woofer is going to be bigger, say, 6 to 8 inches, something like that. And that's because of partially the laws of physics and also efficiency. Smaller drivers are better at reproducing higher frequency sound. Larger drivers are better at reproducing lower frequency sound. You probably know this already. Inside a two-way speaker, you're going to have something called a crossover, and it's going to split that frequency response into highs and lows so that each driver only plays what it's best at playing. So you're not trying to get tweeters to reproduce bass, that sort of thing. The thing with these Bose speakers is that they are full range, meaning it's just a single driver that's being tasked with reproducing the entire frequency spectrum. In terms of physical diameter, they're going to sit somewhere between a tweeter and a woofer. They're not going to be giant, they're not going to be tiny either. Like in these Bose speakers, they're about 4.5 inches in diameter. Now, in a three-way speaker design, we would typically call that kind of driver a mid-range because then you would split the frequency 3 ways, and due to its physical size, it'd be best at playing mid-range frequencies. Well, they can still be best at playing mid-range frequencies even when used full range, which is why we need to do some shaping to the sound to get them to sound decent to us. If you were to look at a frequency response graph of just a full range speaker of this size, let's say you've got low ends and high ends over here, and we're not going to like pick any specific values or numbers, but a graph of a mid-range size speaker like that is probably going to look something like this. You're going to have kind of a frowny face because you're getting a lot of mid-range, but not a lot of bass and not a lot of treble. Now, how Bose can get away with building speakers that have just a single, mid-range size driver and get them to sound good, in quotation marks, is that they apply some equalization. Now, in the case of these commercial speakers, these 102s, they expect you to use an external, what they call system controller, basically an equalizer. And I could go that way if I wanted. I could buy one of those on eBay. They're 20 or 30 bucks. Not a huge expense, but they take up extra space. It's more wires that you have to deal with. There's another power plug involved. It kind of goes against the concept of a very simple, small, cheap stereo setup for the garage. Suddenly now I've got a whole bunch of extra components involved just to get these things to work. I don't really want to do that. Now, in the Model 101s, the consumer version of the speaker we're working on, inside there's actually a little passive speaker network, and it applies some shaping to the sound. Now, I don't have a pair of 101s to take apart and investigate how they do it. However, I got very lucky and found some pictures online of someone who had taken apart their 101, and then elsewhere on the internet, I found someone who had measured the values of some of those components kind of roughly, so I had an idea as to what they're doing. Basically, what's going on is internally in the 101s, because Bose doesn't expect you to use an external EQ or a system controller or whatever, just hook those consumer speakers up to your regular stereo receiver, they're doing some EQ shaping to the sound to get a curve that looks a little bit more like this. Now, the components don't necessarily bump up the low and high frequencies, but rather push down the mid-range. Because of the information I was able to find online, thankfully, I think I can reproduce that setup with some spare parts. Let's take a look at what's involved in that. Okay, so here are the parts we're going to use to build that little EQ network thing to get around the limitations of that mid-range driver. And this is as close as I can get to what actually comes inside a Bose Model 101, the home consumer version from the factory. We've got a 1.5 millihenry coil or inductor. We've got a bipolar 4.7 microfarad 100 volt capacitor. We've got this 10 ohm 25 watt power resistor. And then not necessarily for EQ reasons, but for other reasons we'll get to in a second, I've also got this 4 ohm 10 watt resistor. Now, these three together are going to be what forms that EQ curve thing. If you remember in the diagram, the natural frequency response of those mid-range drivers is like a frowny face where it's peaked in the mid-ranges, not so good on the low end and the high end. This circuit's going to kind of counteract that. The coil is going to act like a low-pass filter, so anything below a certain frequency is going to get let through to the speaker as is. The capacitor is going to do something very similar in that it's going to be a high-pass filter. Anything above a certain frequency is going to get let through as is. And then the resistor works on basically what's left, in this case, the mid-range. Because it's a resistor, it's going to reduce the power, so it's going to effectively act as a notch filter to depress or reduce the amount of mid-range frequencies that the speaker plays and allow the low and high end to basically be better heard. It's not going to boost them necessarily, but if you depress the mid-range, it's effectively kind of the same thing in that you've got a better ability to hear the lows and highs that the driver is actually going to produce. Where this resistor comes into play is, if you remember earlier on, I was talking about how the speaker driver itself rates at about 1 ohm of impedance, whereas most speaker drivers rate between 4 and 8 ohms. 1 ohm is way too low for a regular audio amp to be able to handle. The vast majority are not built for that. This resistor, wired in series after this network, is going to help bring the overall impedance of the system to somewhere, I think, between 4 and 6 ohms. We won't know for sure until we're done. And there's some caveats as to how you can measure that with just regular electronics tools, but we'll cross that bridge when we come to it. All right, so let's try to assemble this like the same way that we saw it get done kind of from the factory. I think we end up going something like this. Or do I want to go? I kind of want the longer lead, I think, on this side. Yeah. Here's where things get interesting. I kind of need to stack all this up. Actually, I think I want to go this side. So you can see, before I get too far, you've got these posts. They use the same mold on all the different models of speaker that were visually similar to this one. So even though from the factory, they don't have anything actually mounted to these screw posts, in other models of speakers like the 101, they use these posts to mount components to. So I'm just gonna take advantage of that. And then I've got this washer and this screw. Okay, cool. So that's actually all mounted on there fairly securely. Now we'll get this capacitor in play here. So And then on this side, I've got these three that kind of go together. So the coil, this big resistor, and the capacitor are all wired in parallel. And then I'm gonna get this other resistor in play in series on the output side. So I'm then going to wrap this around here. And look at that big nasty mess right there. That's okay. And I've got a similar nasty mess on the other side over here that you kind of can't see. I'll show you that in a little bit. The other thing that we need to do is the wiring tune from the speaker. Now the ground wire is fine. I don't think the ground wire going through the transformer is really going to have a detrimental effect on the impedance or anything, so I'm just going to leave the ground wire fine. But I need to get this red wire, which comes from this switch, out of the way. Since this is wire wrapped, I don't really want to leave the wrap itself on the speaker terminal, so I'm just going to try to kind of undo this. I'll just tuck that wire down somewhere inside the speaker where it won't make contact with stuff. All right, so now let's get a little bit of solder going on these terminals and make these connections and all of that. Doesn't have to be pretty, it just has to work. And then the last bit is dealing with a wire going from what I guess is the input side of this to the speaker terminals. Get in touch with my inner Big Clive soldering skills here. Okay, you can see I just wired the big resistor, the cap, the coil, and that red input wire all together. All right, so here's the input block, and you can kind of see the transformer back there. This white wire is what feeds the transformer, so I'm just going to unwind it. Okay, so that's off, and I'll just tuck that in there somewhere it won't get in the way of anything. And then now we simply solder our new input wire to that terminal, and you're probably only going to see my hands because it's pretty tight down in there. Something tells me solid core wire would have been a better choice for this. Oh well. Yep, that's on there. A little ugly, but it works. Okay, so we've got the multimeter going. I've got it set to ohms. Caveat on this. This is just a multimeter measuring resistance. Impedance is not the same as resistance. One of the big things to know is that when you use just a multimeter to measure something like a speaker, it's only going to take a snapshot at one frequency. Basically, whatever the meter is designed to do that measurement at. There are specific meters for measuring impedance on speakers. This is not one of them. This is just a general electronics multimeter. However, considering that, one, this is just a garage system, and two, I don't really care, it's close enough, all right? I know you guys are going to give me shit down in the comments because I'm doing it wrong. Whatever, it's close enough, okay? Anyway, so let's measure first the raw driver itself. Like I said, these generally are considered to be about an ohm, maybe a little bit higher than that. Okay, yeah, so like 1.5, 1.6 ohms. So this is like a little over an ohm. I've seen some say that it's actually 1.2 ohms. So the fact that the meter's measuring like 1.6, I don't think we're too far off in what our real numbers are going to be compared to what I can tell here with the meter. So now let's measure it between our new circuit. So I'm going to put the positive end on the input side of this little filter network, and then the negative terminal is going to go on the negative of the speaker. Yeah, 6.5-ish ohms. I'm happy with that number. That's something that a regular audio amp is going to have no problems driving. In fact, there are a lot of speakers out there that are rated specifically for 6 ohms. That's a number that I'm happy with. Now, the question is, how well does this filter network operate in terms of dealing with the natural sound of what this driver wants to produce and making it sound better? In quotes, again, air quotes, better. This is a Bose speaker, argue amongst yourselves. Anyway, let's do kind of a head-to-head and see if it makes that big of a difference. So there you go. We kind of made it sound a little bit better. I mean, it is what it is. The laws of physics can only take you so far. This would be much better if it was a proper separate woofer and tweeter with a crossover network. But you know what? For sound in the garage, just playing music while I'm working on a project, and for the low cost of free $99, I'm not going to complain with the results. This whole project has actually been fairly inexpensive. That amplifier was something like 45 bucks. The parts altogether were like 10 bucks, 15 bucks, somewhere in there. And then just a little bit of time to put this all together. So anyway, I hope you learned something. I hope you found this interesting in the very least. This is the last part of this kind of small audio series. If you want more episodes about audio and electronics, this kind of stuff, let me know. Otherwise, if you like this video, I would appreciate a thumbs up. Be sure to subscribe if you haven't already. You can follow me on Twitter and Instagram @thisdoesnotcomp. And as always, thanks for watching.